Hello students, in this video I am going to inform you about the software project estimation. Once a process model is finalized for a software development, the software project management begins with a set of activities which are collectively called as project planning. The project planning consists of 5 major activities. They are estimation, about the topic we are going to see today, scheduling, risk analysis, quality management planning and change management planning. In estimation, before a project can begin, 3 kinds of informations have to be estimated. The cost for the work to be done, the total amount required to complete the project, the resources required, that is the human resources required, time that will elapse from start to finish, that is the project duration. Project estimation. Estimation for a software engineering requires 3 kinds of skills. One is the experience. The person involved in estimation, if he has enough experience in the previous projects also, we can rely on the estimation. The access to good historical information. If the estimation information related to the previous projects are available, estimation will be easier. Also, the courage to commit to quantitative predictions when qualitative information exists. That also will be helpful. The factors that affect the reliability of estimation. The first one is the project complexity. If we take a fresher, he may feel even to develop a simple e-commerce application as complex, whereas a team which has already developed more than 10 number of e-commerce application may take the current project with the moderate complexity or simple complexity. The second factor is the project size. As the size increases, the interdependency among various elements of software grows rapidly. The third one is the degree of structural uncertainty. If confirmation of requirements and ease of compartmentalization are not sure, we cannot rely on the estimation also. There are variety of estimation techniques. The first one is based on the previous project experience. If the customer, business conditions, software engineering environment and deadlines are roughly equivalent compared to the previous project, then the estimation from the previous project can be taken. The second method is the conventional estimation method, which is mainly based on the decomposition techniques. Here the entire project is broken down into many tasks and every task is estimated. The software is sized in terms of either lines of code or function points. Empirical estimation models. These models basically use empirically derived formulas to predict the effort as a function of lines of code or function point or object point. Automated tools. These tools implement a specific empirical estimation model, and based on the values supplied, these models will help us to find out the effort required. Empirical estimation models. These models reflect the population of the projects from which it has been derived. So the formula for every empirical estimation model is derived based on the similar projects. So these models are highly domain sensitive. The formulas take the form E equal to A plus B star EV to the power C. Here A, B, C are empirically derived constants, and E is the effort in person months and EV is the estimation variable, which can be either LOC or function point or object points. But the majority of estimation models have some form of project adjustment component that enables E to be adjusted by other project characteristics like problem complexity, staff experience, the development environment. So if complexity is more, E has to be given more weightage, more effort will be required. If staff experience is more, productivity will be high. Development environment is good, productivity will be high. So these are all called as the project adjustment components. Cocomo Ii model. In the classic book on software engineering economics by Barry Boehm, he has proposed the Cocomo Ii model, that is constructive cost model. This model can be applied in 3 levels during the development of your project. Application composition model. This is used during the early stages of software engineering. The second one is the early design stage model. Once the requirements are finalized and a software architecture is established, we can use this model. The third one is post-architecture stage model. That is, when the implementation is going on, during that time also this model can be used for the estimation. This Cocomo II model particularly uses object point as the sizing information. Object points are computed using counts of the number of three informations. The first one is the screens, that is the user interface between the software and the user. Then the number of reports to be generated. Then components likely to be required to build the applications. So every object instance also is associated with a level of complexity. The complexity levels are simple, medium and then difficult. How the complexity is decided? It is actually a function of number and source of the client and the server data tables that are required to generate the screen or report. If less number of data tables are referred, we can say the screen as simple complexity, whereas if more than 10 or more than 20 tables are referred to display the information in a particular screen, we can term it as difficult. Also, the number of views or sections presented as part of the screen or report also decides the complexity. So once the complexity level is determined, the number of screens, reports and components are weighted according to the following table. So the complexity level simple, medium, difficult are given different weightages. For example, if we take the screen, for the category of a medium, 2 is given as the complexity weight. So the object point count is finally determined by multiplying the original number of object instances with a corresponding weighting factor in the above figure and summing to obtain the total object point count. Suppose there are 5 screens, 2 of them are simple and 3 of them are medium, then 2 should be multiplied with 1 and 3 should be multiplied with 2 and we should take the sum. Similarly, we should take for report and we should take for 3GL component. The final summation should be obtained to get the total number of object points to be developed. Suppose the component based development is followed or reusability is planned for the current project, then a certain amount of components can be reused. So in that case, the total number of object points to be developed will be reduced from this particular count. So the new object point equal to total number of object points we have estimated into 100 minus percentage reuse divided by 100. Effort estimation. The project effort is estimated using the formula estimated effort is equal to NOP divided by PR productivity. This stands for new object points to be developed and this stands for productivity. The productivity rate in fact will differ from organization to organization and individual to individual. So the developer's experience and the organizational maturity both are taken, ranging from very low, nominal, that is average, high and then very high. Based upon that, the productivity rate will be given in the table. So we'll see an example now. So we have to use the Cocomo II model to estimate the effort required to build a software for a simple ATM. So note the word simple here, which produces 12 screens and 10 reports. So total number of screens are to be developed 12 and then 10 reports. Both of them are simple complexity and will require approximately 80% as the new software components. So 20% are reusable, 80% we have to develop as new ones. So assume average complexity and average developer environment maturity and use the application composition model with the object points. So let us summarize first what is given in the table form. So here number of screens to be developed are 12 and number of screens to be developed are 10 and then 3GL components 0. Complexity is simple for both the categories. So the weighting factor for the simple complexity for screen is 1 and report is 2. So 1 into 12 will give you 12 and 2 into 10 will give you 20. There are no components to be developed for the application. So 12 plus 20, 32. So totally we have to develop 32 object points for the given project. So it's given that 80% of the components have to be newly developed. So remaining 20% can be reused. So new object points to be developed. For this we have the formula here. So we supply the values. So 32 object points we have to develop and 20% is the reusability. So 100 minus 20 and then divided by 100. So which is giving us the value 25.6. So among the 32 object points we have calculated, we can almost use up to 6 object points and then we have to develop newly 25 to 26 object points. Since productivity is given as average, we can assume that the productivity is 13, for which we can refer the productivity table, and the effort required is computed using the formula NOP divided by productivity. So new object points is 25.6 and productivity is 13, so which is equivalent to 1.96. So for this simple ATM system, we need 1.96 person months for the development. Thank you.